delivered as a key part of a program which was developed by the FAO and sponsored by the government of China under its South Cooperation Program. That program is being offered to the CLAC entities, Community of Latin American and Caribbean States. That funding has provided access to key pieces of equipment and also the funding of this training session. The access to Kim's expert tuition, I think, also is a key contribution that has come out of this. And with at this point, however, I just want to highlight the presence of a few especially invited guests. Obviously, we have Kim here virtually with us, but also too, we have Mr. Juan Sheas, who represents the agriculture organization. He is the country representative. I don't see them as yet, but we anticipate having a couple of representatives from the Fisheries Division and also to the Chief Technical Officer, I think, for the Ministry of, I forget the correct title, but those who actually issue the licenses and for telecoms unit. To do a bit of introduction, Kim, I think as most of you already know, California native, has lived in the Caribbean, I should say, more than 20 years, and is a marine ecologist by training with extensive field research and experience, deep passion for using technology to develop innovative approaches. During her 20-year tenure in the Caribbean, she has worked both with SERMES and as a research assistant and developing their work on geospatial, drone, and participatory mapping, but also to as the head of the entity, Marine Spatial Information Solutions, Inc., and the designer of this course. With us, Senior Juan Sheas, the FAO representative from Barbados. He's also the Trade and Markets Officer and Gender Focal Point for the Caribbean. He's an economist by training from the Dominican Republic, and I think at this stage I'll cut myself short and introduce and invite Mr. Sheas to actually give us a few brief remarks as well.
Thank you so much, Frederick, your colleagues, Dr. Baldwin. I'm very happy to see your face for the first time, actually. I'm very happy to ascertain that indeed this whole issue of new technologies and digital technologies is something that can attract young people, because perhaps in one or two exceptions, everyone here is young or very young. And I'm very happy to see that. Dear colleagues, we are gathered here today to mark this significant milestone in the advancement of sustainable agriculture and disaster risk management as we celebrate the closing ceremony of the drone training program. This initiative, funded by the FAO China South Cooperation Program, plays a critical role in the response and recovery from the impact of COVID-19 on rural livelihoods and food systems in countries of the Community of Latin America and Caribbean States, CELAC. In partnership with the Marine Spatial Information Solutions, this program has sought to equip technical staff from the Ministry of Agriculture and Fisheries and the Barbados Agricultural Development and Managed Marketing Corporations with advanced skills in unmanned aerial systems, spatial analysis, and participatory data collection techniques. These skills are pivotal for enhancing agricultural productivity and building climate resilience. Today, Barbados joins 6 other Caribbean nations, namely Dominica, St. Lucia, St. Vincent and the Grenadines, Grenada, Guyana, and the Bahamas, that have benefited from FAO's capacity building efforts on drone mapping and geographic information systems. Through these networks of learning and collaboration, Barbados has not only gained valuable insights from the countries that were already part of the program, but will now contribute to the next phase, and also the next phase. The lessons learned here will support upcoming projects in St. Kitts and Nevis, starting in December, and in Jamaica in the first semester of 2025. FAO has documented several benefits and multiplier effects of utilizing drones and participatory GIS for agriculture in the Caribbean, which are worth highlighting. Number one, drones and GIS are not only useful for production management and monitoring, but also play a crucial role in disaster risk management and natural resource management. Number two, this program has provided a practical approach to upgrading skills related to data management and analysis, which will enhance the day-to-day operations of our agricultural ministry. By showcasing the potential of cutting-edge technologies, this initiative can inspire youth to engage in agriculture, helping them to see beyond traditional farm operations and recognizing the value of technology in shaping the future of agriculture. FAO remains committed to supporting the continued advancement of skills and knowledge gained during this first phase of this program. The next steps include additional training in intermediate flight planning, ability and risk assessments, disaster impact analysis, and the use of multispectral drone data for crop monitoring. By enhancing these capabilities, we are taking a decisive step towards improving agricultural productivity, strengthening risk management, and building climate resilience in Barbados. Through this collaborative effort, the trainees have successfully mapped 6 national demonstration sites covering over 1,000 acres of agricultural lands and fishery space. Our dedicated training team, comprising 8 pilots and 10 analysts, has mastered precision crop mapping and production monitoring, applying these technologies to ensure sustainable land management practices. Additionally, the development of a UAS policy and commercial operation manual, compliance with international standards, has set a strong foundation for the future use of drones in Barbados. This project is not only about introducing new technologies, it is also about empowerment. By integrating data-driven insights with local knowledge, we are empowering farmers, communities, and policymakers to make informed decisions to promote climate-smart agriculture and resilient ecosystems. As the impacts of climate change continue to pose increasing risks to our region, these efforts are vital in safeguarding our natural resources and ensuring food security for future generations. I would like to extend my sincere gratitude to our partners in the government of Barbados, as well as to the participants and trainees who have shown unwavering dedication to the success of this program. The support of the FAO China South Cooperation has been instrumental in making this initiative a reality, and I'm confident that the skills and knowledge gained will continue to benefit Barbados for years to come. Thank you for your attention, and I look forward to witnessing the lasting impact of this project as we move forward together in pursuit of sustainable development and climate resilience. Thank you very much.
Thank you so much, Frederick and Juan, for your openings. You definitely set the stage correctly. I am not going to blab right now. I think everybody here knows me, Dr. Kim Baldwin. I've been working with this team for the last 2.5 months, and I'm really excited to present to you what we have been up to and the accomplishments. As I mentioned, this is just going to be a rapid fire type of presentation. It won't be boring. We're just going to I'm going to quickly go over what we've done, and then the students are going to show you what we've accomplished. We mapped 9 sites across the country and over 4,000 acres in Barbados in the last 2 months. So we're all here today because we understand the benefit of using drones. Drones can help us in many ways, but the main things is that it actually makes our work a lot more efficient and effective, and many times much easier to use. So drones are revolutionary environmental management. They allow us to easily collect data and map areas that were previously inaccessible in a fraction of the time and cost of traditional surveys. But what excites me the most, and I hope this team, is that when we pair drone technology with geospatial mapping and analysis software, they can allow us a real-time understanding of the environment to support informed decision-making. So the focus of this project today is looking at using drones for agricultural and disaster risk management. This is a drone photo that was recently taken in the Grenadines with Hurricane Beryl. But there's a variety of ways drones can be used for disaster management, and focusing really on the real-time aspects of being able to collect data, analyze infrastructure, inspect things, plan evacuation routes, and understanding the impacts both environmentally and on livelihoods before and after disasters. Agricultural applications for drones are numerous. Agriculture is one of the largest industries in the drone mapping world today. There are a variety of softwares and apps that can help us very quickly identify and use this technology for weeds and pest management, planting and spraying, livestock, soil analysis, as well as damage assessments. The students will go into all of these applications in the coming. So why are we using drones for environment or agricultural mapping? They're very easy to use and cost effective, but really they allow us to capture data quickly in real time and accurately, and then act on that information. And we are then able to analyze with the use of all these apps and geospatial tools information so that we can react quickly and inform our decision making. Furthermore, drone technology, especially the technologies we've been using the last few months, are extremely easy to use. All right, they're non-technical, they're affordable. They use a lot of cloud-based infrastructural resources, which helps us, let's say locally or nationally, that we don't need to have fancy computers and cloud storage systems to get this up off the ground. They also work without data. So this is another huge benefit. The students will tell you that by using these web mapping dashboards, it has allowed them to start to learn GIS and to be able to create geospatial data, as well as to share this data amongst a wide variety of audiences. This project here, this is a project that I have done now in about I think this might be the 5th country for FAO. I developed this project during COVID, actually in Barbados, working with BADMC is where I actually developed all this course in the curriculum. So it's really exciting that this has come full circle and that I've gotten to come to my home country of Barbados and put on this program. So what is the focus of this program? As I mentioned, this program started in early August and is concluding right now. It was designed as a blended course with some virtual components as well. But actually, because I was in the country, we did this primarily as an in-person class. So these students in this room have gotten more than 150 hours of face-to-face training with me, plus the support of my online drone training academy. They also, my approach and what they have done and worked on is a practical skills-based approach where we've learned theory and then we go out and we implement and we practice. So you can see the sort of their skills that I've been testing them on and training them on over on the right. And you will see from them in a moment sort of the results of this approach, which is a very practical skills-based approach. And how do we do that? It was by going out and executing these processes on the right at 9 different sites over the last 2 months. Who are we? The drone team composition, as I think one mentioned, is comprised of 8 pilots and 10 analysts across 3 different agencies in Barbados. The project was led by the BADMC, and they invited the Ministry of Agriculture and Barbados Fisheries Division to participate in this training. We've been taking a collaborative approach across all of these agencies in this entire project. You can see on the bottom, this was the pre-training skills assessment of where we started. The majority of people had little to no drone flying and geospatial apps and analysis type of experience. They were all, though, very heavy in terms of going out and collecting data and field surveys. We will be doing another post-course assessment right now, and the final results of where do they feel like they are at now will come out in that final report, which will be out in the next week or so. So I kicked this off with a 1-week intensive flying and mapping boot camp. That was back in August. We did that. So that was really to get everybody on the same page, to teach these pilots mainly how to fly drones safely and professionally, and an introduction to using drone and geospatial technology for agricultural and fisheries disaster risk management applications. A main component of this project also was to provide and develop a UAS policy and commercial operations manual, which is a mandate of the government of Barbados, as well as most countries around the world. So what did we, you can see here what this policy comprises of. And we didn't just read or browse over this policy. We actively implemented and practiced all of these procedures at all 9 sites over the last 2 months. So this has been very applied, and we've done it again and again so that we can really get a solid foundation in these protocols. We've been working very closely with the Barbados Civil Aviation as well as the Prime Minister's office. And we learned in this class not just national regulations, but global regulations and regulatory agencies. We learned about national and global and regional rules and regulations for drone policies and flying procedures. We learned the difference between recreational flying and commercial flying. We learned about licensing and registration in Barbados. All of the drones that are now owned by the BADMC have been successfully licensed and registered by the students themselves, as well as we've learned how to request flight permissions in Barbados, which must be done for all drone operations that are conducted in the country. So as I mentioned, I drafted at the start of this project an operations manual, which leads step by step how all flight contact, all the procedures. We're going to get into it in a moment, but we've been revising this as we go along so that this policy that was drafted, which was the template, is in alignment with all those national policies, but also the policies of the BADMC and the other ministries. We learned about, as part of this policy, flight request procedures. So each one of these bubbles here requires a certain number of steps, which the students will touch on, as I will in the following slides. But really, a main focus of this class really was on data. Because if we are really going to take this forward, we need to have good quality, consistent data captured and collected. We need to have metadata, which the students have learned a lot about data management, data handling. Having a standardized procedures and protocols for data is effective to use this information for informed decision making. We learned about flight planning, conducting risk assessments, site inspections, understanding our environment, and using pre-flight checklists. As the students know, I train them a lot on how to use ArcGIS Earth and Google Earth to do desk-based assessments and error and threat management assessments. So again, these are all procedures and policies that are required by law in Barbados for commercial operations as well as internationally. So even if these pilots went somewhere else in the world, if they applied these protocols, they would be at or above international standards. So this is just an example of one of these risk assessments and what we are thinking about and planning for in each and every mission that is conducted. We've learned how to use, when we're out on site, flight safety checklists, data sheets, and also how to handle and manage all of this data. We've learned a lot about operating in high-risk areas, such as areas in congested areas or near ports, airports, etc. We've learned how to handle these types of things. We've even learned how to unlock the drones so that you are able to fly in these authorization areas, which require special permission by air traffic control and national security of Barbados. So the students will talk about how we learned and we actually flew in one of these areas down by Oistins as part of this training. We've learned about all the various drones that are out there, the different makes, the models, and the applications for each one of these drones. Drones in recent years have gotten very niche specific. There's agricultural drones, there's photography drones, there's inspection drones. So we focused on the various drones, but also the payloads or the different sensors that are available so that we could understand when and how to apply the various technology. As part of this project, FAO provided BADMC with two different drone models, the Mavic 3 Enterprise Multispectral, which is an agricultural high accuracy mapping drone, as well as the Air 2S, which is another great drone. And we also learned how to use various flight planning apps for these different drones as well. We focused a lot in the first half of this class on learning how to use a drone geospatial software called Drone Deploy, which allows us to plan the missions, conduct flight surveys, as well as process the data and analyze it and share this information. And then the second part of the class, we were full speed in this class. We jumped on and we moved on to more large scale agricultural mapping and monitoring techniques, as well as focusing on the analysis. So we go out, we capture the data, but what are we going to do with it? How do we analyze the data to create useful information for agricultural and fisheries management? So the Mavic 3 multispectral is an advanced drone that we learned how to use. We were not able to dive super deep on this drone because this is still an introductory class, but the students learned how to use the flight planning app, which is specific to this drone. We learned a lot about high accuracy mapping, how to use and the purpose of RTK versus PPK, which is post-processing of high accuracy data. We learned about multispectral sensors, their various applications, as well as the techniques for creating and collecting multispectral data, which has its own special rules. And we learned and we discussed how this could be applied to various applications that were of interest to the students within this class. We concluded the last few weeks really focusing a lot more on the data creation. So once we've processed this data using the Drone Deploy web mapping platform to do QA, QC of the results, and to use these analysis tools to create information. We learned how to export the results by downloading them, but also how to share them out as maps or URL links so that people can easily and share this data remotely, as well as, and last but not least, we learned how to create annotation reports. How to, once we create this information, how can we share it? How can we create automated site reports? And so the students will be sharing with you a lot of their results in the coming slides. And last but not least, we learned about geospatial data, an introduction to GIS, to participatory mapping, and how can we integrate drone data with other software out there, whether we're integrating it with ArcGIS, but also various apps that are out there and AI tools, such as plant count tools. There's applications and integrations with John Deere tractors, so that once you map an agricultural area, it can be sent by robotics out to take action. We also learned how to bring geospatial data into Drone Deploy and overlay that on our drone maps, whether they're KMLs or CSV tables, etc. So where are the accomplishments of this project? Over the last few months, we learned how to use 2 drone models, 3 different flight planning apps, and we successfully mapped 9 different national sites across Barbados. 7 of these were agricultural focused and 2 of these were focused on fisheries applications. The students developed over 100 flight surveys during this class, and we mapped over 4,000 acres of land in Barbados. I'm really proud of this team. They've worked really hard. I pushed them very hard, as they will tell you, and we successfully have created 3-dimensional geospatial data at all of these sites, and not just these data products. They've actually annotated these maps and created analysis and baseline information, which they're going to share with you shortly. So right now, I'm going to roll it over to the team so that they can show you a quick snapshot or glimpse at what they've done and what we've accomplished and the skills and knowledge they've learned in the last 2 months.
Good morning, everyone. You're one of the team representing BADMC, and this is Tiana Hurley, Devon Blade, and yours truly, DeAndre Stephen. BAF is one of the sites that are managed under the BADMC. And the farmers there mainly produce bananas. So after 2 hard months of dedication, we came up. We thought how best the drones can be used for our purposes along with the Ministry of Agriculture. We have here on the screen baseline mapping. So this can be used to measure the size of the plots allocated to the farmers. Crop monitoring, so we can check the crops for pests, diseases. Development, we can use it for specialized projects such as the forage project. Production estimation, accurate assessments of crop yields and growth patterns. Disaster management, both disaster assessments of damage to crops. Infrastructure and soil due to natural disasters. Engineering works, surveillance, and of course, spraying. precision application of herbicides, pesticides, and fungicides to the crops.
Okay, that's it. All right, that on here, my task is to explain the machine we use for the mapping of MAFS and P-UAS. It's a small, like affordable one, so hopefully we can get more. This is affordable. It works often so that we can edit the map as we're out in we don't have like this. And the drone will actually fly the map, and then we come back, we can upload it, and it'll be accurate and correct. It has obstacle avoidance, that means any trees or anything around it, the drone will separate itself and try to damage itself. And with this drone, we get like a time of about 30 minutes, depending on the wind and stuff like that, which would impact battery life. We get about 30 minutes with like, and after 1 kilometer in range, we get a little glitches and stuff, but it's good for 1 kilometer to get the mapping this. Okay, 120 meters, this is 400 feet. It took us to complete this entire map of BAB, 72 minutes it took us, and it actually was 417. So you can see here, each dot here, each blue dot here represents a picture. I can go further in depth by taking each picture and seeing the actual picture itself, the actual photo itself. That can identify features like what crop, solid land, and stuff like that. I can add even more information on each picture each picture that is captured. Total acres is 289 acres, and we have to say we did that in 72 minutes. That would take us about a week and a half in normal trucks and walking. And we did extra things like videos and a panorama, which is the 360 view of the entire area. And the pictures we have here is the Earth Station, which is here, which is good for accuracy, helps the accuracy of the drone. And a ridge, which is somewhere around here, which is about 60 meters above ground level. We've got here with Diana.
Okay, good morning, everyone, again. We are focusing on 2 maps. We focus on the Arco Mosaic map and the digital elevation model. So basically, in these photos, you will get this kind of result by going into the app called Drone Deploy, which will turn on elevation model, and you'll be able to see this particular map. Each color has a represents some. Red represents that is not healthy. Green represents that is very healthy, and yellow represents is moderately healthy. So we're going to focus on annotations, and I will give you a brief definition of what an annotation is. It's a text or graphic on a map that provides information to the person who is reading the map. Okay, so the annotations that we focus on gabions, focus on cisterns, main roads, and allocations. So each of these represent, so we have blue, we have yellow, and we have purple. So also, we could use these types of maps, or we could use these annotations to help with the monitoring, which we will monitor like crop health, we monitor like pest pressures, natural water courses. We could also use it to allocate land, plot sizes, elevation levels, identifying access roads, and identification of crops. So the types, the usage, and issues.
So let's reiterate the uses for drones. We can use it to monitor soil erosion, use it to monitor crops, access roadways, use it for land clearing, and to place farmers on the lands.
Good morning, everyone. We are presenting there's a combination style representing, which is the NU and change your name. And feed production lands are within the close proximity. I am David Coppin and
I'm Rodney Branford.
presenting. All right, next slide. This site would have been one of the first sites chosen for really field work. It was selected because ANU is responsible for promoting research, extension, and development activities like that sector. And they're also tasked with evaluating nutritional forages and rations. Obviously, they will be planting fields of forage and spawnage in order to be able to monitor it and track it. The next site that would have been in proximity, the farmers feed project, the farmers empowerment and plantation, right? Which is reducing levels of poverty, increasing employment, particularly vulnerable groups, including women and youth, and facilitating the sustainable development of the agricultural sector through improved access to land and inputs for agricultural production and development. So obviously they're not in peak. So it's important to be able to track their production. Yeah.
Good morning again. In order to do this mapping, we did two things. You see examples of both things right here. We use the point map as the app I was used. And next one. You can see the information of the two flights right here. This is the total area of the MU and the program.
So what you can see here is that we have the full or mosaic map. You see everything looks green and healthy. If you're just doing it as a first glance. But when we now go into the actual one of the functions that you can use the drone for to be to analyze the plant health. Next slide. To the actual health of the area. You see that although the first map would have shown a lot of green and so on, in terms of looking at plant health, you see a lot of areas of red.
The adaptation report, we said here, see we have measured the roads, the fields, different buildings for the annotation reports. And this will then produce and the player. And we thought about this area.
So based on doing annotations, we're able to get measurements for settlers. So you'll be able to see the acres in production, which would be the green colors, total 32.15. Lands not in production, which would be the purplish areas, 9 acres, and then what we would have estimated would be recently harvested land, 24, and that would be the pinkish colored areas. And then obviously then the roads would be in the yellow and the orangish color. So 450 meters of main roads, and then we also have the buildings in blue, which would be 7,700 meters squared across. So based on, as I said, this was one of the initial sites that would have been examined. So as a follow-up, we recommend that you can schedule flights based on the feed farmer crop cycles. Similarly, also schedule flights based on the projected farm harvesting cycles. You can also schedule that can help monitor the productivity levels of the feed farmers. In terms of mapping, you can go back to the map of irrigation lines and also to make sure that farm plots are mapped so that when the fields are clear and so on, that when persons start back production, that they actually stay within the bounds of their application and so on.
We presented on Plantation. The drone that we used was the DJI P-UAS, like altitude of 120 meters. 3 flights were done. Total flights was 6. Flight time of 40 minutes. We took 454 images and we mapped the area of 200 meters. We also did 4 360 cycles. So the baseline mapping results, we had a flight time of 31 minutes and 25 seconds. And this we took 400 photos and the resolution was a 3.7 megapixels. Elevation was 14.6 megapixels and the 4 panels were done at 100 meters, 75 meters, 60 meters, 35 meters above ground level. And some important sites was a pump house, pond and wells.
Good morning all. We have field mapping agricultural applications, field and infrastructure monitoring, identifying roads, irrigation management, crop types, land usage, lighting issues, crop health, and crop damage assessment. Next slide, please. Monitoring site results, analysis, reporting. We have 8 annotations reported, which was 1 shed, main road length, which was 991 meters. We also have 2 cultivated plots.
Thank you.
That's all.
Hi, everyone. My name is Scott Marshall. Name their bikes. This is Gabriel. If Lears is the area where from Poyer to Bridgetown, that's where it is. Big farming area is under the tutelage of the BADMC. And we have, I can't tell you exactly how many farmers we have there, but we have many commercial and allotments as a farming district.
applications were to want to know how big it was, what we have, what we're working with, the farmers planting, that sort of stuff, the boundaries, and the health management. And really read off anything really well. We'll keep it sharp. All right, we did 4 flake surveys, 4 flakes. The time was 43 minutes. And they didn't have clock, but that's what it was. 567 images. We got some beauty shots, some glamour shots, as well as some fast shots. We did a panel, warm panel. And we just keep it short and keep it moving because they don't want to be repetitive. All of us is going to stay close to the same thing. Next, we did 150 acres. We stopped laughing. We did 150 acres and our was it ready for some forest centimeters per pixel. And we had a good time flying the tunnel. Different colors, elevation, we monitored elevation of the land, different things like crop health. And we also took the measurements for we have in Lears, we have a catchment that makes water available to all the farmers there. I think on the other side it has different breakdown, can't reach. We also have 4 water tanks, 1 storage shed, 11 farm access roads. And basically the drone mapping application, it helps us to do, it's a big area. We do a lot of walking in the field. Everyone doesn't have vehicles or bus fare, but the drone can actually cut down the amount of time it takes for us to extend the extension services to the farmers there. You can. Next slide.
Yeah.
Thank you.
Morning. My name is Bradley Ford. Production estimation, disaster management, insurance claims, surveillance, and that's it. So this is the 75 years, and we did each dot, as Devon was mentioning before, each dot represents a photo taken, and this is our for mapping the baseline area that we did from there. This is the flat lines that we did. And this is our actual video that we did of the actual site here. It's 406 images. This area has about 109 acres mapped, and the resolution was 2.9, and the accuracy 1.8 meters. Yeah. Next slide. This just shows a 3D image of the whole vertical area. This shows the elevation of the heights that we did, plant health of the actual area, and this was our results that we did in the reporting. Right, so this is just some of the recommendations that we would put forward to the Ministry of Agriculture. Monitoring frequencies, commitment, support from the stakeholders, and the stakeholders were involved like farmers, agronomists, farm operators, agricultural consultants, insurance companies, government agencies, NGOs, general public. That's it. Thank you.
Morning, everybody. I'm Charles Howard from Soil Conservation. I was very excited about this course. I was excited for the Ministry of Agriculture because I was seeing that we were going in terms of incorporating new technology and we were on the board. So I was excited for myself and my team members. I was disappointed too, but I will probably say why a little later. Now, during the course, we discussed, team members had the opportunity to discuss what we wanted to see or what we wanted to capture sometime during the course. Now, the team from Soil Conservation Unit, we consulted and basically we agreed that we will select Bawdens, Greenland, Sedge. Why? Because it captured a wide span. Residential, eco-conservation, crop health, and as well as agriculture. So we decided this is what we will do. The task wasn't easy. It was let me just pick it up. Now, what, in terms of the area, we have an agricultural park. There is stabilization of revegetated terrain. There's water catchment, pavement infrastructure. There's an orchard, as well as public infrastructure and access road. Activities, ecotourism, a range. In terms of what are some of the monitoring activities can be done, biodiversity, disease and pathogen, a wide range. Some of the stakeholders, Ministry of Agriculture, BADMC, farmers, the local community, and Ministry of Environment through NCC. Thanks. Now, I will go through the actual process in terms of what we did for this area. As I indicated, the country risk was a medium because it had a variation in terms of terrain and the size was large. First, we actually prepared for flight requests. This, what on my right is basically a Google form with the request, and we had to include a KML of the area. Next, we then applied safety risk assessment, and we review, and then we did additional planning. So because of the size of the area, we had to break it up into 3 different flights. Now, this is the area that we broke up. We had Greenland, Bawdens, Sedge. Now, we planned and then we input this information into the remote control and it generated a flight plan. What you see here is the flight plan for that area. After that, we executed the flight, but note well, you don't just go and fly the drone and that's it. You have to document what you are doing during flight. So you document what time to start, what time to end, battery percentage, and you document a range of things. Next. Now this is actually the area, but this is the number of photographs that were taken. So we had over 1,300 images. And what you see there, that's actually the plan of how the photos were taken. So you would know that there's slight overlay in photographs so that you can actually have an accurate depiction of what's there. So 8 panels, and go ahead, Kim. This is the result of all of that planning and planning. This is our map. But the accuracy was very high. Okay? We then had the opportunity to analyze the data. This is where I'm looking for from the BADMC. Yes, this is where you get excited because we were able to monitor, to capture the water catchment. We were able to measure and determine the level in terms of we can really monitor and determine the level as well as you can calculate your volume over time. Right? Here, this one is actually the coconut orchard. And I did a plant health analysis. Note well, I would say that's one of the areas that I would flag for the training because we just had a cursory discussion in terms of plant health. So I definitely would, since we're Ministry of Agriculture, need training in analyzing and determining plant. And now this, go back in, this is what basically was captured in relation to the given structures that were there. And this is important to soil conservation because we want to also monitor what is happening with our structures out in the field. Now you can go ahead. Now, in terms of these are my recommendations for the future, and Ms. Trishana Curtin will now come and speak to us about our analysis on Greenland.
I'll be presenting Greenland Station. My mapping applications are to the animal. Detecting an animal is sick or injured, track animal movement, also count animals in a large herd quickly. Mapping. Baseline mapping for agricultural planning and management. Measurements. Surveillance. Animal heat prevention. Management. Disaster of assessment and construction due to natural disaster. Pastures, unified areas of overgrazing, fertilizing the pastures. I use two different types of drones, the entry end and the DJI. I use the entry end to fly half map and do a cardio. The Air 2X, the fly video and a 3D model. And these are the pictures taken from the 3D model. Here is a video of the 3D model. The 3D model was flown at 50 meters, 10 minutes. Image captured 136, 11.6 acres were mapped. The resolution was 1.8 centimeters and the accuracy was 0.8 meters. My baseline marker. Right. So this is the Greenland half map. I use the Maverick 3 multi-spec. The time was 34 minutes, flown at 120 DSM. Two drones flights, 580 captured, 400 acres map, and the resolution was 2.7 centimeters. The linear plan was 100 meters by 100 meters. 6 minutes flights captured 238 images and 72.4 acres map. My recommendation, monitoring livestock, drones provide us with real-time monitoring, which allow us to make decisions quickly, they consider ability to cover large areas and map quickly and accurately, mapping frequency at least twice a year as well before and after natural disasters for agricultural data collection and monitoring over the season. Thanks. Perfect.
That's one, Kim. Thank you. Right, so the site that we flew at Poyer. The site that we flew, this site provides income and employment for approximately 50 farmers. The person that are working at the falls under the agencies of BADMC and under their Wakefield program. And by doing so, it ensures that we have some level of security being continued. Now, some agricultural applications that would have been considered at the Mount Poyer location, soil field analysis. We are going to go into it, crop monitoring, land use, and overgrowth. This is particular interest for the BADMC as well as soil conservation because we work in tiny applications that you don't see coming up. For example, then we have a lot of overgrowth at the BADMC, they have landscape there. With a mission that is executed, we can see the amount of area and we can calculate the time it's going to take for one of our pieces of equipment to go and clear land. And our equipment is in very high demand, so this is a very critical application. Next one, we're going to look at the base map. A base map was flown using the H2S. We use the application drone deploy that Ken would have mentioned. Area is a large area particularly, and as a result, when you look at the flight lines that we have here, split it into quarters. As a result of that, it took about 10 flights, we flew at 120 meters, and many value changes were needed.
That's one.
Next one. This map that we did with H2S. What we did was that we did a base map with H2S, and then we flew the multi-spectrum, which is a more detailed map over that. So we had a basic map, and then we went into greater detail. Nicoma's going to go into that momentarily. Thank you. And we did about 541 acres. Those 1,100 images were captured. And you can see the resolution and the accuracy. Next one, Kim, thank you. I'm just going to go straight into the end.
Please. The entry, as you can see from here, the accuracy of the drone is a lot better compared to this small area was mapped. This was to deal with the crop health. You can see these are some. This is good. This one is good. As you can see, we have the processing of the results from the entry. You can see the NDVI, the SAVI, the OSAVI, and the RDVI. And again, the accuracy is very, very high on these drones. These are some applications to the multi-spectrum. As you can see, we have crop health monitoring, soil analysis, with estimate yields for crops and erosion. Some monitoring strategies we can do after we have flown the drone, always go and ground truth. We will also like to fly in multiple different conditions so we can get a vast idea of the fields that we're working with and how they produce all the different conditions. Thank you very much.
Good morning, all. My name is Poyer, and this is Singh, and we represent Fisheries Division. We were given the opportunity to be a part of this drone program to be able to see how best we can use a drone in our line of work. Be it that it is a very unique field that we work in, not necessarily on land. We are both land-based.
All right, so for this course, we have to sit down and decide the applications in fisheries and how drones would be useful to us. So we have our vision and mission just there so that you can read, so that you can see how this aligns with these applications that we have for drones. So we have national inspections, so that persons will have to go out there and do it on their own, that the drones could fly over and do it themselves. We have disaster management. We're gonna get deeper into that because it's very relevant for our presentation. We have the mapping of landing sites, fishing grounds, FAD, fish aggregation devices activity, which are big buoy-like type devices out at sea. We would like to monitor them. Search and rescue is very important, especially if lost the boat or if something is missing. It's important to have the drones there to go and get them. We also have illegal, unreported, unregulated fishing. Drones will help to monitor that in terms of crime. We also have the monitoring of sargassum, which affects our fishing activity. And more recently, we have the marine spatial planning aspect of it, which will help with the physical planning and mapping out the areas. For fishery sites, we did Bridgetown and Oistins, which are the two largest fish landing areas. And we used the DJI Air 2S and Maverick Spectrum. For the Bridgetown Fisheries Complex, we particularly did disaster management assessments. We did boat fountain and a great water issue report. As you can understand, this course came at a time where Barrow had just hit, the fishing industry was very vulnerable, and the drone application was much needed in this course. So we did different flight plans. We did a 3D model of the Fisheries Division. We did a corridor plan. We did panoramas, and we did a photo plans, all flown at various heights. We also did Oistins with the Maverick. We did another disaster assessment, and we did a corridor plan. So now, prior to 2024, prior to 2024, Kim would have done these sites, and so we had like baseline data to compare 2023 to 2024. For Oistins in particular, there is a special permission because it was a flight authorization zone, because it was so close to the airport. We had to get special permissions to be required to fly in this area at 100. We had to also call air traffic control. You usually call air traffic control before and after flights, but this was especially relevant because planes fly overhead at Oistins, and we didn't want to interrupt them with the drones. We didn't want to have any incidents or collisions. So the DJI drone was unlocked, that particular one, and there were sensors to warn us of the incoming flights. So you can go ahead. So this was just a flight plan of Bridgetown that we did with the Maverick. It showed us the mapping area. It also showed us the duration and the amount of photos taken as well. You could go on. So this is a video we have of pre-barrel and post-barrel. So as you can see, pre-barrel, hopefully it plays well. The breakwater was still intact. The boats were there. And then post-barrel, you can see the breakwater is destroyed. There are less boats in the complex. And this was our situation here at Fisheries. So we decided to take this approach heavily in disaster management to showcase what the drone is capable of. You could go ahead, Kim. This tool in drone deploy can help us to count the amount of boats in the complex. So while we were doing our damage assessments, it was hard to quantify how much boats were damaged. So if we have an idea of how much boats were in the space, whether on water or on land, we could get a more accurate figure of what was damaged and to what extent it was damaged and how many boats were damaged. So this tool in drone deploy was very useful for counting the boats, but this obviously happened afterwards. But as you can see, it was 145 vessels in the water and then 57 on land. There are other annotations that we thought were useful. After the boats were hauled up and out of the water, there was not a lot of space for them. The purple dots represent boats that were in the helipad where cars usually parked. So this is a new addition, hopefully not but a new addition to we also have the length of the damaged jetty. But as Cal points out, it's right there, so this will help the persons re-engineering the jetty to know the length that was damaged, to what extent. We also have the lengths of the regular jetties, if those would also need to be re-engineered. And these were just some annotations that we thought were useful for our disaster management analysis.
Excellent.
Okay, so Cal will take over from here for our next site for Oistins.
Yes, good morning again. As you can see, this is that's a map of the Oistins area that we've done with M3M multispectral. 50 acres, 6.5 kilometers, 8 minutes. It took us to do this map. Just to complete it. And so this is a 3D video of the map that we did. Here we have two annotations of issues, and each dot that you will see, as mentioned before, would be each individual photo taken by each one itself. Some more annotations and issues that we would have found when we did the map. You can tag certain areas that you deem a problem or something of interest. Right here we have the fish market itself, the boatyard, situated. Then these two would be damages caused by barrel. Here, would be a dock that was completely destroyed. Here we have a shoes, which was damaged and or destroyed by the hurricane. Yes, look. Lessons learned, restricted zones, especially at Oistins. Must keep in mind what not to do. You must have special permission to play these areas. Before, funny enough, when we were playing the Oistins map, there was a gentleman basically observing what we were doing, and we came to realize that he was a former
Head of Civil Aviation Authority.
Yes.
He's the ex-director of civil.
Yes, ex-director of civil aviation. He did not know what we were doing, but in his eyes, we were doing something wrong, saying that we were playing in a restricted zone and planes were coming. But with the training by Ms. Baldwin and having special permission, we were in the regular waves, so to speak. But from his eyes, he was going to call the police on us. Another lesson to have in mind, situational awareness. What is around you? Who is around you? Yes, and point all these things. And management and processing, how to manage and use this data to be able to use it to speak to other people that want to know more about these areas. Pre-flights, site assessments and visits. As Baldwin said, do a drive-by, more or less going and do a pre-survey of the area before you actually fly it. So you would know where you can fly from, where you can take off from, see what are the obstacles in the area that you know you have to avoid pre and post flight. And the head thing that you can use would be the KMLs from either Google Earth or ArcGIS. This will give you a layer or boundary of the land that you wish to map. And this then can be used or imported both in the Mavic and the Air2S. And be flown at different times. Flowing. That is it for Fisheries Division.
Thank you.
Good morning, everyone. My name is C from BADMC. So just gonna do a brief review in terms of partners we've collaborated with. We've had more or less BADMC as a central focal point. And then from here, we have collaboration with Soil Conservation Unit and the Minister of Agriculture, Food and Nutritional Security. That collaboration also with the Greenland Livestock Station, also under the Ministry of the Planning Unit under the Ministry as well. We've had collaboration with the Barbados Fisheries Division, FAO, more or less, or I don't want to say government, but stakeholder we would have this initial training under, right? And overarching the Ministry of Agriculture and Food. Structure that we propose is to have more or less based on this organizational chart, you'll have the director who will more or less oversee all the management of the drone unit. Under there, we have a breakdown of different roles, one being a UAS engineer. That person will be more or less responsible for the actual management and maintenance of the actual drone equipment. You have the coordinator who would more or less manage the team and all the operations that are within that scope. And also the other things in terms of updating protocols, managing from the other persons under that line. And there you have the pilot in command, and that person more or less is responsible for the operation and must be a safe operation of flights. And that person actually makes the call in terms of determining what is safe, what is unsafe. So they actually made that determination. We also have, which I forgot to mention, but above that is the data manager, who more or less has the responsibility in terms of managing all the data. Everything that would have been captured, all the imagery, they manage all the data. All processing stuff that actually goes to the data manager to have that. Under there, you have persons who would be data collectors, have observers, which will be persons within different entities or organizations who may want to engage with the actual drone. And we also have the data analysts who would be responsible for making that data what you know it to be and being able to understand it in a way that everyone could right. Next slide, please. All right, within the drone, this is more or less the procedure in terms of creating flight requests. You also have within that planning of activities. From there, you have the flight feasibility and safety assessment, which is very critical to every operation. You have the flight approvals, which will be done under, which are the approvals that come from the Prime Minister's office. Then you have the assessment and flight planning, in which you will conduct before you actually do the actual flight. From there, you have the conduct of the flight, and then you have the data management and the post-processing part, which is the final step in the entire program. Next slide. All right, so some of the strengths of the drone team, more or less you can see here on the slide, you have the equipment, that is the strength, and actually being as well, and having the capability of 17 persons being analysts as well as pilots. That's another thing being one of the strengths of the unit. Some of the weaknesses we have found is that the ability to more or less additional storage, that would be a challenge because when you want to have that storage off site, you don't have a data more or less to travel to have that power source. The annual license, which is really another hindrance as well. You have the drones being owned just by BADMC. That could be a hindrance to other entities as well because they may want to utilize it for a specific scope of work. Well, they would more or less have to come to the BADMC in order to have that facilitation. Some of the other things being a weakness, you have liability insurance, which is more or less very expensive, and you have the flight time. That's one key thing to that flight time. You need to really talk or lobby scholars to be able the more experience you have in terms of your flight time, the better the capability of the unit. You need to have more flight time. PSCC is further training in terms of you'll be able to have greater in-depth analysis, particularly as it relates to crop monitoring by using the multispectral drone. And we do have some other agencies, I think, in the ministry, I think, we'll have some more as well. And another opportunity would be to have a drone unit dedicated more or less at national level. And that is one thing that we see that would be a great opportunity. And that will be able to help progress more or less progress. Now we could offer services to other institutions, and that would be another opportunity for us. Of us more or less as a governmental agency would not want to have it as a service. Well, maybe. Some of the threats to that is that the great collaboration. Some of the other tracks in terms of having the unit is that every flight may not always be possible because there are certain environmental conditions. At the end of the day, it's more or less an electronic device as well. So you need to be cognizant of that. Some of the other tracks would be in terms of the different mandates. We know that each individual entity may have a different mandate, and not often that is aligned. So that is one of the things that will be more or less create friction. There's some limited knowledge in terms of software and GIS analysis. That's another thing that we need to bolster definitely in terms of increasing our knowledge and experience in terms of like full accurate geospatial analysis tools. So that's something now being electronic, and as with all devices, even as simple as your phone, there's always the possibility of having glitches and failure. That's just a list in terms of what happens in terms of this one. So now, more or less everyone would have spoken regarding different, just to bring everything into context at a national level, ways in which we can actually utilize the drone technology and the analysis tools. For example, in terms of the agriculture census, we can look in terms of mapping crops, we can look in terms of livestock, actual pasture, we can look in terms of mapping the areas that have pasture production and different clusters of farm plots and farm areas. Then it would be in terms of agricultural insurance. We could look in terms of creating that baseline data that then you can see where there are actually these areas of production. And for example, if there happens to be a disaster, you can have that analysis to compare from that baseline data. There's also in terms of the management, irrigation management, another one in terms of mapping, you can map watersheds. You can use that to more or less create your plans for where you're gonna situate certain areas of production. One other thing would be in terms of the aquaculture project, which we all know that BADMC has more or less a mandate. What we can do in that area is to look in terms of monitoring where there may be areas of algal blooms and look to see where we can more or less look to treat those. We can also look at monitoring movements of where there are different species of aquatic weeds as well. Another thing would be in terms of the management of the tree houses spring. It gives us the capability then to more or less plan and monitor our activities as it relates to ensuring the stream is flushed and cleaned. Also look at where there is all infractions that occur along the stream flows. But another thing would be in terms of the soil care project. You can look in terms of being able to have precise locations geotagging, in terms of those locations where we have had soil samples being taken, as well as at some point in time with the multispectral, also be able to look in terms of a depth layer of soil analysis as well, and have that comparison with the actual data. Another thing would be our project, and this is in terms of being able to monitor areas where there's erosion, and you can look in terms of your terrain, look at the analysis of your terrain, and be able to guide in terms of where the intervention, and basically that would be the planting of custom grass in those critical areas. One other thing is in terms of our crop production escalation, which we know is the initiative now, and more or less one of the mandates and the Minister of Agriculture as well as BADMC. We can look in terms of monitoring the farmers. We have earlier intervention as it relates to the pest disease management. There's a whole scope, a whole category of things, uses for the drone technology analysis. And last but not least, the coverage eradication project. This is another way in which you can utilize drone technology. How you can do that is that you can more or less look in terms of identification of areas of growth and be able to target those areas as the points in where you have that intervention. You can also look in terms of monitoring your control strategies as well, because you already have had that baseline data in terms of the areas to target and monitor the effectiveness of your control strategies. Great, that's it from my end.
Great. Thanks so much, Leslie. And those presentations were amazing. So I'm just going to close this last slide with some of my preliminary recommendations and next steps after working with this team over the last few months. There will be a more extensive list and explanation in the final report, which will be shared with you all in the coming weeks. Also, I did not make it apparently clear, but we have drafted, I just saw a message that civil aviation had to leave. They just had to leave the meeting. They were here, Christine Marcus. But what we have now produced or will be released in the next week is the final draft of this operations manual, which can be shared then with the government agencies for final review and approval. So next steps and recommendations in implementing this drone unit, but also for institutionalization of drone technology across the Ministry of Agriculture and the government of Barbados. Let's see on technical difficulties. So first, expanding training, building on this I've built a very strong foundation with this team, but we need to focus now on building their skills, finding ways to get these teams out there flying to maintain what they've learned. But also this technology is always changing. So you need to stay on top of it. This is tech, this is AI, this is tools that, as we know, computers and tech are just rapidly proceeding. So finding ways, some of my teams have Fly Fridays or excuses or national projects that you need to get all these team members out there and flying will be extremely important. Furthermore, continuing this with advanced mapping skills, high accuracy, digging into that, as well as the analysis of GIS, remote sensing, so that these teams or the team members can not just use the types of information we saw today, but be able to export the data out and use this with GIS and remote sensing to do more intensive agricultural analysis. Also, in terms of infrastructure, there's a lot of good equipment out there, but ensuring and planning and understanding the heads of departments, the government agencies really need to sit down and do an understanding of what support is needed in terms of their agencies, but also for working in national way, regional and national collaboration in terms of data and information. Regional in terms of there's other agencies we'd want to share this with if there were a disaster like CMIA or other insurance claims, maybe FAO or United Nations, or there's some other agency, SEDEMA, that you want to be able to share and work with in a remote way and need to have that type of infrastructure planned for. So what I've recommended to the team, and I will elaborate on my report, is really this need, what we found out working with the various agencies and them getting back and talking to other people, as well as talking to planning and surveys, civil aviation, Prime Minister's office. There are a lot of different agencies that own drones, that have software, and have received different levels of training. So really a national audit should be done within the government public sector to see what do we have right now, because as our teams have learned, not all drones are equivalent for different applications, and drones and maybe MOUs can be developed to share and trade not just equipment but also people and skills in case of an emergency or national projects that need to be implemented. So again, geospatial data and a geospatial unit or a drone and geospatial unit really is probably something that is needed, but also the collection of this data in a standardized way. So making sure that all agencies that are involved either in this team but across the government of Barbados are collecting the same high quality data, and that it's handled, managed, named, etc. and metadata is created in a way that we can actually trust and reuse this data so that this work is done very effectively and efficiently at the lowest cost. So again, BADMC to start with, but then amongst the partner agencies, let's say across the ministry and then maybe across the nation's public sector in general, understanding and developing this internal structure of the team roles, the flight permission requests. How are the agencies going to communicate and integrate and work together on this moving forward? So a lot of discussions need to happen now that we understand what the drones are capable of, the data, etc. I think that the teams teams now have that understanding that they can have good or at least be technical advisors to the heads of departments and the ministers and PSs so that we can actually take this thing forward. As I mentioned, just building these partnerships and collaborations for this data-driven approach, but also developing the collaboration and partnerships with a variety of levels of stakeholders. The nonprofit agencies, maybe, or the universities that are doing research, as well as the farmers and fishers on the ground, being able to work with them and teach them what these drone maps can do for them, and the information that can be created, and so that we can start using the data to sit down and show them the maps and map their local knowledge on these drone maps will be extremely useful for many of the identified applications. And last but not least, I highly recommend some sort of long-term technical strategic support guidance mechanism for these teams. I did this for the University of the West Indies for over 5 years after I trained them. Why? Because when you're new, you're a little overwhelmed, but to think of that long-term vision and plan of what steps and how to proceed, it takes a lot, because mainly you're not a focused drone professional. You're like me, you're a jack of all trades, right? You've got your normal job, you've got all these other things. And so to keep things forward and stay current on the tech, the industry, the apps, the software, the drones, and everything is a lot of work. So I would recommend some sort of longer term guidance or strategic plan that is developed to actually take this whole thing forward. So that is the end of it for me. I just want to say I'm very proud of the team, but I'm going to hand this off to Riza Spencer at FAO for any closing remarks that she has in regards to the FAO projects, objectives, etc. Riza.
Hi, everyone. Presentation.
Do you have a slide, Riza, or no?
Yeah, you have slides.
Oh, so I'm going to do end share and let you guys take over. Oh, just reading to the group while we're setting up here. I just am reading the message from Christine Marcus at Civil Aviation. She said the training looks like it has created a skillful and responsible community of drone operators. We look forward to working with them moving forward.
Good morning once again. My name is Riza Spencer. Yeah, it's not able to, unfortunately, to bear with me with us. It's a brief presentation of the self-operation, digital transformation and innovation in agriculture project, which funded this activity. So the main part of the project was to support COVID recovery in the CELAC countries with the focus on strengthening agriculture and food systems. The main objective was to transform agriculture and food systems and increase the resilience of the livelihoods of food and agriculture-based technicians and professionals. The geographic scope of this project was 12 countries being implemented in Barbados and Guyana with the Caribbean region. The project focused on digital hubs and digital applications, with digital applications being implemented in Barbados. So noting that the Ministry of Agriculture had the FEED program, which is the Farmers Empowerment and Enfranchisement Drive, which focuses on reducing agricultural imports and increasing national food security. It also focuses on training farmers. There was a good synergy or crossover between the two initiatives. And we look to provide a framework for digital agriculture aligning with this FEED. So we noted before FAO's invention, the main issues were lack of comprehensive digital tools to map and monitor agricultural lands, disjointed mapping efforts, and limited monitoring for crop production. We also had limited soil data to guide crop production and optimize resources. And lastly, we had limited collaboration amongst, going back to point 3 with limited data on soil production. Another component on this project is dealing with utilizing soil sensors and monitoring soil health. And then this part, which we dealt with the drones, and we're going to link those two parts so we can have a comprehensive soil map, soil and land use maps to guide the ministry as well as other agricultural technicians. So after this initiative, we noted that we've had the creation of a drone team, a dedicated 18-member team with representatives from the Ministry of Agriculture and BADMC. We're able to comprehensively collect and monitor data, noting that we
We're able to give 4 drones to start this initiative, and that through the training with Dr. Baldwin, you were able to map over 4,000 acres, corrected, and it says 1,000 on there, but over 4,000 acres of farmland. You were also able to improve your capacity to monitor your agricultural areas by creating digital map of the farmlands. And additionally, you are looking to pilot a training program or modules in collaboration with the University of the West Indies for young farmers, teaching them a 3-module course on geospatial analysis and technologies, incorporating the drones as well as geographic information systems. And as Dr. Baldwin mentioned, that we were able to create the UAS policy, and as she said, the final version will be shared next week, gone through rigorous review and collaboration with the Ministry of Civil Aviation for that development. So next steps, so expanding our initiative, we noted the ministry-led expansion of mapping the agricultural zones or the outstanding agricultural zones to create, as I said, the integrated agricultural land use plan. We also have noted that Barbados has expressed interest in the phase 2 of this project, the CLAC phase 2, which we are in the process of developing that project document, which would then focus on the advanced drone training, phase 2, which would look at the multispectral band analysis, focusing on crop health, plant health, soil health, as mentioned earlier by the colleagues from the Soil Conservation Unit, and looking at AI-driven tree analysis and crop counting to help all units in terms of production and plant health. And that's it. Thank you guys so much.
All right, I think I could get control here again. Share. All right, thank you, Riza, very much. That was a great. All right, I don't think that, is there any questions that the audience has there, or can we proceed to the final part of the presentation? Is there any comments or questions from the audience? No? I'm not seeing anyone, I'm not hearing anyone. I guess the answer is no.
I guess I would put it marketing. It's important to explore how drones can help with monitoring. Drone. Yes, the Caribbean Institute for Meteorology and Hydrology, they have their monitoring platform that uses the standard precipitation index. It's always linked to where the rainfall stations are. So it's possible using that data to inform where you flood flags and look at reporting the drought impacts. I just thought about that as I was listening to the presentations. And of course, we are huge, so we have a lot of interest in water. And we did use water all these in our damage assessment complex to help us identify the submerged and partially submerged vessels. Also had some video that was taken that helped to inform the diving operations of the Coast Guard. And we're also interested in using the underwater drone to look at hull integrity to our inspection process. So just interesting comments, but I think I want to say I'm very impressed and happy to see a lot of young people in agriculture in terms of the presenters. And on our end, we are grateful for the opportunity to participate. I'd like to be included in phase 2 meeting. Estimates now on what they need for on water as well to support our operations. I don't know if many of you know that we have our initiative called DigiFish in terms of our integration of technologies to promote fisheries management. A lot of work has been done with vessel monitoring systems. We're looking at installing some smart scales and onboard cameras to support that initiative. So we will also loop the drones into that as well. So thanks again and well done all the presenters.
Thanks. So Shelley, I just want to make a couple quick comments there. First of all, my next drone training is underwater drones in St. Vincent in a few weeks with FAO. So I can keep you updated on that in the future. But I wanted to make a point about those integrations you were talking about. So this class was not my more advanced intro to GIS and integrations. So all of the drone data, and we touched on it, but we didn't actually integrate it, is the usefulness of this data integrating with other national remote sensing data sets, like you mentioned. rain data, water temperature data, other types of field surveys and collections, and how do we integrate this drone data with that data using GIS to better understand issues, trends, and model things. So that's a great point. That is like, this is where the next step is, and you hit it right on the head there. Yeah. Any other questions or comments?
Marshall from Ministry of Agriculture. Hi, everybody. The question is, well, I missed the first part of the presentation. It was at another meeting. But the question is this: is there any particular protocol for the security? Are you flying over people's houses and private areas, separate and distinct from permission to fly in certain sensitive zones? After you have taken footage and whatnot, is there provision for security of data? A number of the islands have training already. Is there anything in place for that to manage the security?
Yeah, we definitely learned about doing pre-flight desk-based assessments, as well as when we're out on site, where you can and can't fly, as well as getting special permission. We also went over when you're flying over areas, let's say farming and field areas that, you know, are owned, let's say, by multiple people. Obviously, we're flying at a certain height above ground level. But also, what steps can you do, such as putting, as I recommended to the team, when you're flying an agricultural area, putting information out on the GIS channel. You need to get special permission to fly over certain public or private lands. That is something we do in our assessments before we go out and fly a mission. And then if you're talking about data security in terms of the security of the data that is flown and processed and stored, that is stored in the drone deploy software in the cloud, we can also bring it down. But that is also a very secure. They have all kinds of firewalls. They're government agencies in, I think they said over 100 countries in the world that are using it, including the United States. So that types of security is also considered as the type of data security that you're talking about. But the data handling, processing, and access to that information, again, this is what I said in my final recommendations, are some of those things that need to be thought about and worked out, especially if you were to scale this to a larger level in the country. But those are all points that are noted. Great, thank you. Any other comments? If there's not, I just want to say that I am extremely proud of this team. I work them hard, as they will tell you. But I hope that now, and if not in a week's time, once they get some rest, they'll be able to look back and smile. I do feel confident that I have placed a very solid foundation in this team. There's still a lot more to learn. They've really just learned the tip of the iceberg, but I do believe that we have a solid foundation, and they understand on a professional level using high quality commercial standards. The one closing note I want to leave with the team is to be safe. And we learned a lot of protocols, and they probably hate me for all the checklist and the procedures, but you need to follow these. It's when people start getting lazy and they skip steps that accidents happen. And the last thing the Ministry of Agriculture, BADMC, and the Fisheries Division needs is for some sort of accident to happen. And then once the trust is broken with civil aviation, these other agencies, everything falls apart. So please continue to practice what I've taught you, and to take your time to learn things, not to bite off more than you can chew at the beginning, and get your skills out. They've learned to driven the drones, but now it's about practice, right? When you first get your driver's license, you can get by when you pass your test, but you're not a professional yet. So keep that in mind. But I am very happy for my next slides here, which will be the presentation of our final results here.
Yes.
To kick this off with one, I think there's paper certificates that will be handed out right now, but I want to first announce or make a special call out to one person in particular, which is Trishana Curtin of the Ministry of Agriculture. She was the youngest member of this team and probably the most solid foundational member of this team. I think every team member needs to give her a thanks and a pat on the back, because she single-handedly was our tech assistant. She was more or less the data manager, QAing, QCing, making sure everything was named correctly, foldered correctly, downloaded, scanned correctly. And I don't know if this team really could have done it as well as we did it without Trishana. So I'd like to kick this off by all of us giving her a round of applause for her hard work and dedication. I definitely see a strong, bright future with Trishana and drone technology.
Good morning, everyone. My name is Tiana Hurley, and it's my absolute pleasure to stand here today to give a vote of thanks on behalf of all the participants of the course and the Ministry of Agriculture, Food and Nutritional Security. I want to begin by extending a warm and heartfelt thank you to all who made this event possible. First, the Food and Agricultural Organization of the United Nations, FAO, and the Ministry of Agriculture, Food and Nutritional Security, the Greenland Livestock Station, the Soil Conservation Unit, and the Fisheries Division, your unwavering support and dedication to the advancing agriculture in Barbados is truly aspiring. Your efforts create a brighter, more sustainable future for all of us, and we are deeply grateful. I would like to extend a special thank you to Dr. Kim Baldwin. Your passion for teaching and your expertise in drone technology have opened up a world of possibilities for us. You have not only taught us how to safely fly and effectively fly drones, but also to understand and utilize the data we collect to improve our agricultural practices. With this knowledge, we are equipped to achieve great things and contribute to the betterment of agriculture in Barbados. A big shout out also to drone team members. Your hard work and dedication throughout the process have been greatly exceptional. Give ourselves a well-deserved round of applause for all the efforts and accomplishments we've made together. As we leave here today, let's take this knowledge and apply it to our daily activities, ensuring that agriculture contributes and continues to strive and grow thanks to the skills we've learned. Thank you once again to everyone who contributed to this journey, and I look forward to seeing the incredible impact we will make together. Thank you.
That brings us to pretty much a close. And I think, unfortunately, Kim, you're not here to join us, but it's a refreshing to share our facts. Again, congratulations to all. Thanks again to the FAO for your work and continuing work with us. We will have some conversations as well on a few other projects, so we look forward to engaging with more. And the Fisheries Department, we will be calling. Thank you. Thank you very much. Have a good day.
Great. Thanks, everyone. It was really my pleasure. And thanks again, everybody in the room, for your unwavering support and helping with all the logistics and training and us pulling this off successfully. Congratulations.